The problem statement is find the length of the longest common prefix. So what is given actually two positive integer of array 1 and array 2. So we have to find the prefix of positive integer as integer formed by one or more of its digit. I'll explain what I mean here. Starting from the leftmost digit for the example, like 1, 2, 3 is the prefix of the integer 1, 2, 3, 4, 5. But 2, 3, 4 is not. 2, 3, 4 is not the prefix of 1, 2, 3, 4, 5. Even 3, 4, 5 it is called suffix. This is not the prefix. So starting from the initial like leftmost digit to any up to any number of any position up to any position digit is called the prefix. Like 1 is a prefix for assumption like 1, 2, 3, 4, 5 is given, right? So what are the prefix of this number? 1 is a prefix, 1, 2 is a prefix, 1, 2, 3 is a prefix, 1, 2, 3, 4 is a prefix, even 1, 2, 3, 4, 5 is a prefix. So these many prefixes are possible from 1, 2, 3, 4, 5. Okay. For and let me tell you how many numbers of prefix possible. You can calculate actually. So how many number of prefix possible? If you notice, 5 prefixes are possible. So how many digits are present in the number? So that many prefixes are possible. So how many now? The next question is how many digits are possible in a number? So it is nothing but number of digits. So this symbol sometimes use a number of digits. Number of digits equals to uh, say my number is n, it will be log base 10 of n and plus 1. That many digits are possible. Okay, how are we getting this kind of this formula? See, what do you do to calculate the number of digit? We simply check divided by 10 and plus 1 plus 1. So divided by 10 is nothing but log of base 10. So if I do log base 10 and this number, it will return something like 1, 2, 3, 4. Okay, so I am saying that if I give log of uh, 1, 2, 3, 4, 5. It is not sorry, it is not give this thing. So if we divided every time we're dividing by 10, every time we're dividing by 10, like this 1, 2, 3, 4, 5 is given. Divided by 10, this 1, 2, 3, 4. This is divided by 10 is 1, 2, 3. This is divided by 10 is 1, 2. That's 1. Then done. So how many steps are there? 1, 2, 3, 4, 5. Right? This is how we can do. So 5 digit we can get. So this is how we can calculate. Actually, it is a formula. It is a formula of getting number of digits. Okay. So how many prefixes are also possible? Number of prefixes similarly. This is equals to number of prefixes of a number. Okay. I guess you get it. Okay. Now back to the problem statement. What it has said. Uh, So this is all about what is the prefix of a number. Okay. So common prefix of two integer a and b is an integer c. Assume common prefix of 1, 2, 3 and 1, 2, 3, 4, 5. What is the common prefix? Common prefix are 1. You can say common prefix is 12 because 12 are common. We can say 1, 2, 3 is common. So these are the common prefix. So let's say there is 7 present. So or 5 present. So this is not common. Even though because 1, 2, 3 and 5. This is not a prefix of this 1, 2, 3, 4, 5 number. Okay. So these two number, what are the common prefix? These two number common prefix are 1, 1, 2 and 1, 2, 3. So you have to in this case, what is the longest common prefix? Longest common prefix is 1, 2, 3. So what we have to do? Two arrays are given. We have to compare each and every pair, and find out the common prefix. Find out the common prefix. This is our term, like longest common prefix. This is our term. If nothing possible, if no common prefix exists, then it will simply 0. Okay. So I'm giving you the one example of like no common prefix exists. Like so 1, 2, 3, 4. This is the ARR of 1. And ARR of 2 is like 5, 6. So there are no common prefix. No common prefix. In this case, my longest common prefix I have written 0. Okay, let's see how. Okay, before that, let's see what is the constant. Constant is nothing but starting length could be 1 and length could be 5 into 10 to the power 4. So we have to somehow solve it inside below the big of n square. Okay, fine. And what is the length of a character? Is 10 to the power 8. 10 to the power 8. Length of each. Sorry, not length. The number may belong in the range of 1 to 10 to the power 8. Okay, it could be highest number possible. Fine, then let's see how could we solve the problem. Okay, let's take this an example, and from this example we can solve the problem. So first approach is find out the longest common prefix, and let's find the what is the answer. Let's by visualizing this what is the answer. So here 1 is common from this, so 1 could be maximum answer. Okay, if you notice here 10 is also common. 10 is also common because 10 is also common. So my maximum could be earlier my maximum length. Earlier my maximum length. This is my maximum length. What is the maximum longest common prefix? Okay. Okay. Longest. Longest. Longest earlier initially it is 0. Okay. Can I find anything? This 1 is common. 1 here you can see 1 is here common. 1 is common. The longest would be 1. Fine. Now can I get anything better? So 10. 10 here. 10 here and 10 here it is common. So okay, good thing. So 10 is common, so longest could be 2 as well. So if you're getting 10, you can get 100 as well. See, this is 100. Length of 3. Length of 3. Length 100 is also present in the common prefix. So it could be 3. So it could be 3. Let's see any other cases. Like 23 also common. We can see 23, 23 is matching. So already we have a maximum longest uh, longest common prefix is 3. So why to take 23 because it doesn't make sense, right? In the case correct right now one I have done 22357 this for this number. In this case also if we see for this set of number there is no common with this number, right? But with this number with this 23567 something is common in this number. What is common? 23. So same it is lower than my current longest. So let's see this one. 235 I have mistakenly written a 6. It should be 5. Okay, so now see the 2345 is common. 2345 is common. So whole number is not common. Like it is 23455 and it is 23457. The maximum number is common is what? 2345. So maximum longest common prefix becomes my 4. Becomes my 4. Got it? So now we can let's say let's how could we solve the problem. So okay. So now things like you can say things like this way the brute force approach, like for each number I am go through this. I have to check is there any longest prefix exist or not. For this number I have to go through, I have to visit this everything, I have to check everything. So this should not be our approach because 10 to the power 4, 5 into 10 to the power 4 is the limit of the array. If I do it, it will be squared and it will be 10 to the power 8. Okay, some more than 10 to the power 8, but still it is 10 to the power 8. So it will be give us a what time limit exit error. So how could we kind of solve this faster? How could we solve this faster? So one could like we have to take one array, any array, either this one and this one. We have to compare with each pair, right? With each pair, and I have to find out like what are the how many matchings are there. So if you noticed in this case, see this one, like here something is actually common. Like what are the numbers present in past array? 1, 10, 100, and 2, 3, 4, 5, 7, right? What are the common prefix of 1? 1. What are the common prefix of 1 and 10? What are the common prefix are here? 1, 1, 10, and 100. What are the common prefix of here? Like common prefix is here it is a maximum of 5 species. So 2, 3, 4. Sorry, 2, 3, 2, 2, 3, 2, 3, 4, and 2, 3, 4, 5, and another one is 2, 3, and the entire number, right? 2, 3, 4, 5, 7. So if you discard this number, if you only notice these three number, you can see many things are common already. Many things are common. Like when you are getting this one is already present. 10 is already present. Sorry, 10 is already present here. So many things are common. Right. So what we could do, we can from the one array, from the first array, we can find out the unique prefixes. How many unique prefixes are possible from the first array, and then we can from that unique prefixes. It doesn't matter this prefix come from this 10 or this prefix come from this 100. Doesn't matter. We have to need the common prefix, because whenever we compare this 1000, we can compare this 10 and 100 as well. Right? From this 100 also I can get and I can see it is 10, right? So that's why it doesn't care like from where, I don't know which place this common prefix is matching. Correct. So there's the reason I'm saying, like, let's find out the common prefixes from the from our case, this case. Like from any one of the, you can take any one of the. We have to, like, it doesn't matter take this one or this one. Yeah, you can think of it like, let's take the smaller array or let's take this bigger array. You will understand. It will not later. You will understand. It will not create any effect, because I will also tell you why. But for right now, I am taking anything. Like I am taking only fast array. Okay. Okay. Now, how could we find out the unique prefix of my fast array? Okay, so I need unique set of numbers, right? So state means this is the set where we use a hash set. Okay, so we use s equals to set. This is a hash set or something, but it is a set. Okay, so this is my set. Okay, let's also write the function longest common prefix. Okay, let's say this is our function. This is given what? It is given ARR of 1 and ARR of 2. These two are given. So what I told you, like I need what? A set. Simple a set. So set is equals to my set. Like this is a empty set. Like you can have set what is the, like what is your data structure say, we'll write it that way. It is a set. Okay. Now what we could do, we have to iterate for each and every digit. We have to iterate for each and every digit and find the longest prefix. Okay. So we can iterate. And how could we find like it is a strong 8 digit or not? So for now we have to iterate it. So each number, in the ARR1, I have to iterate. Simple. I have to iterate. Now, wow, I can check in the it's present in the common prefix or not. Okay. So what we could say, like, again, this is my set. This is my set. The first number is just one. One. I will check one is present or not. If one is present, not present, I will add one. Correct. I will say now next number is what? 10. 10. What are the cases of here? 10 is what is the common, like, prefix possible for 10? It is a 1 and 10, right? So I'll check it's a 10 itself, because 10 itself can be the common prefix, right? So I will check like 10 is present in this here or not. If it is not present, I will add 10. Now I have to, what are the, again, common prefix is 1. How could I get 1? Simply 10 divided by 10, correct? I'll get 1. So 1, I have to check 1 is already present. So I will not add it. Okay. Now next case is 100. What are the cases? 1, 10, and 100. Correct. So I'll check if 100 is present or not present. I will add 100. Fine. Next I will do num is divided by 10. So this is 10. Now I'll check 10 is already present. Yes, it is present. Now if 10 is already present, I will not check the last case one, because you see, if 10 is already present, what are the common prefixes of the 10 that should be present in the my set, correct? So I'll not check. I will I'll stop the loop. Like, this is like how we are doing this thing. I was checking, like, until my number is greater than 0, I will take the number and divide it by 10. Like 100, I will check it is greater than 0. I will check it is present or not. And next I will divide it by 10 until it becomes 10, and I will check in there. Next again I will take divided by 10. As of 1 and 10 is not present already. So 1 is should present there, and if I do divided by 10 again, it becomes 0. So 0 don't no need to check. Okay. So until my number is greater than my 0, I'll check. Like, I'll start dividing by 10 and check that my divisor is present or not. This is how we have to check. So hope you get it. So let me write the code, and it will be more clear, I guess. So what I am checking, for each number I am checking if my number is present, if my number, let's say num, or whatever the thing you have the function, like if set dot find, in the set I am finding my number, if it is set true, I'll simply say break the loop, because I no need to so check it, right? But if it is present, then I will add it. Then again, like if it is not present, I will say stop. I'll modify it later. If it is not present, then I have to do what? I have to do, like, I have to, in the set, I have to add that number, in number. Now I have to check the same thing for the number divided by 10. Number divided by 10. I have to do the same thing. So I need what I do, I have to do a while loop. Same logic I will use inside the while loop. So let's say while while my number is greater than 0, I'll check what? If my number is already present, I'll say stop. Stop means here break. If it is already present, then break the loop. It comes after the if statement, that means break doesn't happen. So that means it doesn't present. So I'll simply do add the number, and after that what I will do, I'll simply write it again, like this condition, like number becomes number divided by 10. Number becomes number divided by 10. Simple. Ends of the while loop. This is how it works. And here also, here. So this is how we do, correct? So if you wish, now see, here I am checking the condition. Here I am checking the condition. Both condition I have to check, like number is greater than 0, as well as we shouldn't find if number shouldn't present in the number. These two conditions. So I can merge these two conditions right in a single case. Is number greater than 0 and is dot find of number not 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 present. Find of number num. If it is not present, then we'll add into the number. Correct. Simple. This is how we will create our unique set of prefixes. Okay. Now, unique set of prefixes. Hope up to this it is clear. So what are the unique set of in this 2, 3, 4, 5, 7? What are the cases? So we'll start with 2, 3, 4, 5, 7. We'll check 4, 5, 7. We'll check like 2, 3, 4, 5, 7. We'll check this. Is it this whole number is present in that in there? No, right? We will add 2, 3, 4, 5, 7. Then we will add what? We will reduce the number by 2, 3, 4, 5. We will check whether it is present. No. We'll add 2, 3, 4, 5. Again, we have to check like 2, 3, 4 present or reduce the number and check it is present or not. Not, we'll add it. Then again reduce 2, 3. If we add 2, 3 because it is also not present. Then we'll reduce 2. It is also not 2. Then if I reduce this, it becomes 0. No need to check 0. No need to check 0. Got it? So this is how we check. So this is how we check. Fine. Delete. Now we have to check. Like what is my set becomes. So let's write the set. 1, 10 will be there. 100 will be there. 2 there. 2, 3 there. 2, 3, 4 there. 2, 3, 4, 5 there. And 2, 3, 4, 5 and 7 are there. This is in the set. I'm creating set for this example. Correct. Now, what are the other secondary? Secondary we have to do. Now we have to find the maximum common prefix. Maximum common prefix. We have to find. How could we find? The entire digit can be the common prefix, right? 23. 23 is a common prefix, right? So you can iterate from the entire digit. You can iterate from the entire digit and check it is a common prefix or not. Correct. Is a common prefix or not? Okay. Or what would be the possible? What is another possibility? Another possibility is it could be like part of any number. So whatever it is, again you have to iterate for each and every number, right? Again you have to iterate for each and every number. Correct. So let's iterate and see what we could do. Okay. And for example, instead of 1, let's say 10. We'll understand why I'm saying 10. Okay. Or let's take 100. 100. Okay. Fine. So what did I say? I have to iterate from each number as well. But before that, I need one thing: my answer variable. My answer, that is my currently maximum is initially 0. Now I will loop it. Loop what? For num in ARR 2. Each cases I will run. So in this case, what I will do, I will check what again. Like I will try to take the entire thing. Okay, I try to take the entire thing. I'll check whether it is present in the here. If it is present, that means it could be my maximum. If it is entire thing is present, like 23 is present here, it could be my maximum. So what I will do, I will and reassign my answer. How to reassign the answer? Let's see later. Okay. If next question, let's say 1000. What if it is not present? Let's say this is 1000. If I check entire thing is present or not, 1000 it is present. Correct. 1000 it is present. Sorry, not present. So if it is not present, I will reduce the one length. Okay. So 1000 becomes 100. I will check the rest of the case. So that's why I start taking. That's why I'm not taking from starting from 1 or 100 or 10 or 100 because I have to get the maximum. I have to get the maximum. So maximum could be the whole or could be like remove the last number and I can get the whole. Correct. This is how we can get. Okay. So this is how we could get. So that is we can do like if it is 1000 is there and it is present not present. So I'll take 100. 100 it is present. I'll again update my answer. Okay. Okay, fine. So if I get 100, it is already present. If I get 100 is present, then what is my answer? Answer will be my 3. Answer will be my 3. Correct. Now, do I need to check for 10 as well? No, because I get the 100 is matching. So it is my maximum rate. I shouldn't check like 10 is already present or not. Correct. 10 is already present or not because I get in the maximum case. So I shouldn't care about my less numbers. I shouldn't care about my these things. Like what is the smaller than my current smaller number than my current number? I shouldn't care about it. Okay. So that's why I will pick whether 100 is there and I will break it. So what is my loop? What I am telling doing. So I will take this number. Again while loop. If the entire number is greater than 0 and if it is present, then I get it. If it is not present, then do something. Simple. So here, again a while loop. Let's say while my number is greater than 0. So if number is greater than 0, if it is present, so if that number that s dot find, if it is present of num, if it is present, I will do what? I will reassign my answer. So answer will become answer becomes maximum of my previous answer, maximum of previous answer, and I told what? Log of my current number last one. This is my length of my current number. That how length of my current number. Yes. So this is my answer, and I don't need to check forward, so I can break the loop, so that I can go to the next case. Like break the loop means break the while loop, so that I can go to next. I can go to the next number of the in my error two. Okay. Another thing what I have to do, if while is not present, if this number not present, if this number is not present, if it is false, then we reduce the number, right? So this is becomes num equals to num by 10. Simple case. While loop also ends and for loop also ends. And the end we can do what? Return answer. Return answer. It is my answer. This is how simple this function is. This is the simple case. Now could we slightly optimize this thing? Think of it. How? Why I am saying slightly optimize. So let's dry run first. Then we will think about optimizations. So starting from the beginning. So number is what? 23. 23 is present, right? So 23 is present. So 23 will becomes what is answer? Answer is currently 0. 23 has the length of 2. Answer become 2. Fine. 1000 is coming. 1000. 1000 is already present. 1000 is already sorry, not present. So it will check coming here in each statement, and it will say it is not present. So I will reduce the 1000 by 100. Let's see 100 is present or not. 100 is present. Okay. In this case, my answer become this one. So it will becomes two. It is increase from 2 to 3 because length of 100 is 3. So after that, it will break it. Fine. So it will come 100. 100. It will again come. Again, it will check 100 is present or not. Yes, 100 is present. And but it is a maximum, so it will not update the maximum. Let's add another number here. You can understand why I am adding this another number later. Okay, so after that will come this 2357. Is it present? 2357? No, it is not present. I'll reduce the number by 235. If 235 present, no, 235 is not present, then I'll reduce the number 23. If it is 23 present, yes, 23 is present. But what is the length of 23? It is 2, which is less than my answer, so I'll not update the answer. 10 also is 10 present, yes, present. But should I update my case, or let's say it is not 10, it is 103, not 10. So if 103 present, not 103 not present, I'll reduce the number by 10. If 10 is present, yes, it is present. So I'll try to update, but I can say 10 is length is 2, but my current answer is 3, so I'll not update. So I'll come to here 2, 3, 4, 5, 5. So in this case, is it present? 2, 3, 4, 5, 5, not present. I reduce like 3, 3, 4, 5. It is present. Yes, it is present. So I'll update the number and break 4 and return the answer. So why I have taken these two examples, like 100 and 103. See, for 100, so for 100, what we are checking? For 100, we are checking only once and getting a match. Correct. Okay. So whenever I am checking the 100, that time my current was 3. So if my 100 is totally matched, what could be my maximum? What could be my answer? Maximum it could be 3 or less than 3. That many prefix could be my match. Correct. When I am checking my 103, I am checking twice. Correct. So first I am checking for length 3. First time it is length 3, and next time I am checking for 10. So it is a length 2, right? So do we need to check this kind of things? Like let's say 113, 111 is there. So first in this case we will check for 111 of length 3, then we will check 11 of length 2, then we will check 1, because see 1 is also not present, 111 is also not present. This is how we are checking. But should we check this kind of cases? Can't we optimize this thing? Because see here, my current length is 3. My current length is 3. So whatever I get this number, if the number is equals to my answer, if it is like length of my number is greater than my answer, then only it is like it is worth to check it, right? Otherwise it is useless. It can produce my current, it can produce like there is could be a match of the prefix of length of current answer or less than my current answer. It cannot exceed my current answer, right? Because the length is itself my equals to my current answer. So that's the reason we will in the while loop we will write another condition. If the current number, if the length of current number is already my is greater than my current answer, then only I will check. Otherwise, I will not check. Hope you understand, because I can slightly optimize this part. Okay, so let's do it. So I have to write here on another line, and this is called what is the current length? What will be current length? It will be log of num plus 1 if it is only greater than my answer. If it is the case, then only I will check. Otherwise, I will not check. Okay, hope you get it. So let's now look at what is the time complexity. Okay, let's see what is the time complexity of this problem. Simply, if you see it is a big of n, length of the uh, array, okay, big of n, you can, I'm assuming both are same, like it doesn't matter, and it will be big of n, okay, big of n. What is the maximum I will take? Like it is n1, it is n1 of length, and this is n2 of length, n2 of length, and n is nothing but maximum of my n1 and n2, maximum of n1 and n2. So this is my what n means. So see what is the, let's see what is the this second loop runs. So assume my all of the number in this array at 10 to the power, what is the maximum number? 10 to the power 8. What is the maximum? Everything is kind of 10 to the power 8. Okay, all our number is size of nearly 10 to the power 8. Okay, and assume each will, like each number will generate a unique prefix set. Okay, so how I'm saying, it is a 1 2 3 4, it could be 1, so it could be 2 4 5 6 7. So you can see every time this is a unique prefix set. 3 4 3 7 8 1 2. So like this, like it may generate the sum of will be common, but maximum how many times this loop will run. So it will run, this loop will run the number of what is the length of the number, and I know what is the length of the number. Length of the number is log of num plus 1. So plus 1 is a integer, so describe this integer, it is a big of log of num, okay, log of n, of the maximum number, okay, of this num is nothing but it's a maximum number. So let's say, let's write it down here as well. So n is nothing but my maximum of n1, that is the length of first array, and maximum of n2, length of second array. My, let's say that is m. M is nothing but maximum number. So maximum number has the maximum number of digits, right? So that is the maximum number. So that's why I said, like how many times it will run. It will take how many digits is present in the maximum number. So that is this big of log of m, right? So this will run big of log of m. So how long this will? This is the same. This value is also the same. This num greater than 0. This is also big of log of n. Maximum worst case log of m. So what is my time complexity? Time complexity is nothing but uh, n into big of n into log of n. What is my space complexity? space complexity is nothing but, see how many things it will store. I need a set. How many days it will store. It may store n numbers, okay. And I told you, assume it is generating like unique prefixes for every number, right? So it will also maximum how many prefixes possible. This is the maximum how many prefixes are possible. And what is the maximum case? Like that is the case. It can produce maximum of this many prefixes for each number. For each number it will produce, it will be n into log of 1. This same. Okay. So there is another way you can solve this problem. So that is a try solution. So that will be the try. So how could we solve this problem? So I guess if you are aware of try, if you are not aware of try, please learn try or don't need to see this next part of the video, because it is hard to explain try first here and then explaining. This is already 30 minutes of video, I guess. Over 30 minutes of video right now. So let's put why it is not coming up. This is my number. So try is nothing but it is a, let me tell you a small thing. Like see here how many things are present. This one is present. Try will contain a number of first number like one. If you know try, you will understand. Otherwise, you will not understand. So if you don't know try, please don't watch the video or learn try then come. So let's make a trigraph of this first cases. So first cases it will be 1, then 0, then again 0 is present. This is the thing. And for 2 there will be there will be 3, there will be 4, there will be 5, there will be 7. So this is the trigraph of the first. So next in the schedule the trigraph of the second case, it will becomes 2, then 3, 100, 1000, 1000. For 100, it is already present because 100 is part of this 100,000, so it is not present. Then 2, 3, 5, 7. So 2, 3, 5, then 7. Then 103. So 1 is there, 0 is there, 3 I need. So 103. This is a trigraph. Then 2, 3, 4, 2, 3, 4. Then 5, 5, 5, 5. So this is the trigraph of the second case. Correct. So let's now, I told you na earlier problem we can start solving from any of the cases. Let's start solving the second. Here I am taking this is my ARR 1 and considering this is my ARR of 2. Think of this one. So because of what I am saying, we're taking this thing because here trigraph is more actually looking good. Here it is only single graph, single tree, but here tree is actually looking cool actually. That's why I'm taking it will be good use case. So that's why I'm taking this thing as ARR of 1. Okay, hope you get it. So same problem is all reverse. So for try where I'm using right now, what my dictionary I'm using, you can create a specific class or linguist kind of special class for the try. For I don't like that. I prefer a dictionary for try because my length is limited. So it could be like 0, then it, like each case and dictionary in the case like first I will put 1. In 1 there will be multiple cases. It could be like here only 0 is present. Why to allocate extra space for all the 0, 1, 2, 3, 4, 5, 6, 7. So whatever it will be there, it will be at, like if I set my trigraph of 2, it will be present here. It present 3. Now 3 have two dictionary. The 3 also have the dictionary. And the dictionary it will present 5 and 4. 5 have dictionary, it will present 7. And 7 will contain empty dictionary. And 4 it will contain again dictionary 5. 5 will contain another dictionary, that will also contain 5, and this will be dictionary like this. I guess you are getting what I am saying. So you can understand while doing the code. Thing will be exactly same, but here earlier we are traversing from right to left of each digit, but for try we have to traverse from left to right. Okay, so let's write the function func of, that was my previous, I had to keep the name. Let's copy that name. Copy func of this. Okay, so what I am doing, consider this is ARR 1. Consider this is ARR of 1. This is ARR of 1. So what I need actually, I need a try. So I need a try try will be my empty dictionary, or you can say as map. It's a map, empty map right now, empty map. So what I have to do, I have to iterate each, and for first array I have to make the try tree. Okay. The next array I will compare each number with this try tree, and I can find it out what is the maximum number present. So that's what we will do. Correct. So for this try tree, what I am trying, like I have to just check it. I have to iterating and create the try tree first based on the first one array. So I'm taking this one as array one. Okay, like this. Like right now I need each and every number, like again for each number, let's say number in what, in my array of one I'm doing. Now as I told, for making the try tree, I have to iterate from left to right. So but it is very hard to getting left to right in this number. So better way is converting the number into the string. So I write the string is equals to string of current number. Okay. Now I'll do, now I have to iterate from left to right, right? So if so left to right means not if, while. So while, or not while, each digit, right? Left to right meaning, so I can traverse by each digit, not while as well, each digit, like 2, 3, 5, 7. So again a for loop for each digit, let's say digit D in what, in S. If it is in S, for each digit in the S, what could we do? We could, like, I have to check whether it's present in the try or not. Okay. If it is not present, then I have to add it, then I have to continue. And another thing, every time this try, my content map of map, right? Map of map. So that is I need, I can't create simply, I have to need a current status. So current position. So earlier my map containing only one. This is my current. After I done, I have to add 0 as well, right? So that's why map, like current will point this 0, not 1, because from staying in this route, calculating each and every step, like going to inserting in this position is very hard. So that's why this current will point a current state. Okay. So what I am saying, you understand. So current, make this current equals to, right now this is a try, that is my current. Okay. Okay, I'm removing this graph. Let's build a graph. So current, now I'm empty, so nothing is there actually. So for D in S, for each digit, current digit is 23, current digit is 23, for each digit 2. If it in S, if it is not present, just okay, for each digit I will check if digit is present or not. Okay. So what, that's why I'm checking. I prefer checking with the green color. Sorry. It's blue, assigning is blue and checking the green color. If I have to check if it is D is present. So that current, so right now I am current. This is my current, right? This is my current. Empty thing. If current dot find, it's a D. If it is present, then do anything, or otherwise just do. If it is not present, I want if it is not present. If it is not present, okay. If it is not present, then I'll create what? I'll assign one empty map with that. Correct. So what I'm assigning? So current of ID is nothing but an empty map. Correct. Okay. That's all. After that, what I have to do? Now we have to do what? Now my current should, now I have inserted this 2, so let me add this 2 here. So now my current was outside. Now current should point this to right. Now current can't point outside because this 3 belongs under 2, not outside. So current should point this 2. If it is not present, then assign it. So if it is not present, that's not present. Otherwise, it is present. So present means simple assigning like current equals to current of D. Correct. Hope you are getting it. This is how we are doing, and it will keep building. It will keep building. So let's see how it builds. And the for loop also ends here. Okay, and here it is a map. This outer for loop also ends here. See how it is building. So first my number is becomes what, 23. So it will check 2 is present or not. 2 is not present. It will do current will be this. Current of the will be map. So this will create empty map for 2. So there will be empty space will be created. So current becomes 2. This becomes my current. So right now this becomes my current. Right. So then what it will create, like, then it will be next character. Then this loop ends. This loop ends. So not this loop ends. And now it will come next character D. So current at 3 is come here. 3 will check, it is not present. It is not present. It will create one thing is the 3. Now after that, it will, this is my current. This is my current. So after that it is done, this digit is done, 23 is done. It will take the next number. Next number is what? 1000. The next number is 1000. Okay, fine. Next number is 1000. Now this 1000 will point the again it will point my current. It is try. So this is nothing but this is my outer, like, topmost dictionary. This is my current. It will check what? 1000. That one it will check one it is present or not. So you can check one it is not present. It will add one here. It will add one here. After that, what it will check? Like, then it will, now this becomes my current. Then this becomes my current. Then it will take 0 is present there. No, 0 not present. So it will add 0. And this becomes my current. Then again it will add like 0 because 0 is not present. So it will add into the current. Okay. Now again 0 present, not present. So it will become my current. So this is how 1000 will be done. Now see what you will understand about like 100, or how 100 will, let's see 100. So let's take my current example is 100. And this 100, what could we check? 100, what could we check? 100 will check in the dictionary. It's come first case 1. 1 it will check, it will present. It is present. So it will not create empty map. It's simply like like for 100, my current will be, this is my pointing distance, this is the current. Okay, current pointing the outer level, topmost level. Now it will check 1. If 1 is present in the dictionary, yes, 1 is present. Now current will simply point that 1. So current simply come and point this 1. Then it comes 0. 0 present, yes, 0 present. It will come point 0. It will then again 0. It is 0 present, yes, 0 present. It will come point 0 and it will stop. So it will not create or include anything because it is already present. Okay, so this is the, like, same thing. This will happen for, let's say, 2357. So this is how it will create. Let's say let's take 103 case. 103. So earlier it will, like, case, I'm not taking this to example, will length, like, will make the video longer, so that's why I'm giving 103 small example. So 103 in the case, so I will take 1 it is current right now pointing outer example. Whenever outer map is pointing, 1 is there. So 1 is there, yes, 1 is there. So current come back to 1. Now I have to check 0 is present or not. Yes, 0 is present. So 0 is found. The current will point this point 0. Now it will check 3 is present or not. So here 3 not present. So it will create another thing 3 and current come and point here. And now this ends. This is how it should looks like. Okay. Okay. Let's build a thread. So hope you are understanding like how it is creating the try tree or tribe. This is the tree-based solution. Okay, let's make this as well. 2, 5, 7, then 2, 3, 4, then 4, 2, 3, 4 actually in the level of 5, 4, then 5, then 5. This is my try tree. Now let's see that how could we find the answer. So here also I need an answer variable that will be initially 0. Okay. So answer variable initially 0. So create an answer variable initially 0. So again for each number I have to check, like for each case I have to iterate and check it is present or not, present or not. So you can for loop for each number in AR2, it is checking, right? Okay, so it will be again I have to convert this thing into a string because I can only like here also I have to compare by step, convert by step by step. So it will be string. So a is equals to str of number. Okay, so right now again my current will be also try. So current will be, I will start matching from the beginning, right? So current will be try. Now again for each digit I have to check. So again another loop for each digit in S I have to check in. So that's the answer. So for each digit also I need another local variable to check whether it is, I have to find a local variable. So local variable in the sense like what is my current matching. Okay, so that's what I need, another local variable. And let's say temp equals to 0. Temp equals to 0. Okay, so this is what I am doing. So yeah, fine. So right now what I am checking, if now if it is present, if D is present in here, I'll do what? If D is present, I'll increase my temp value and go to the next level. Okay, let's do one by one. So if D is present here, if not present, no need to checking. Let's say like here one in fast array 1, 2, 3 is present. If one is present here, yes, one is present here. One is present here. Is two present? Two present in this under one? No, not present, right? So that means later on it will not present. And it is not present means it doesn't appear. Okay, let's see what I'm saying. Let's see. So let's take another example one here. Let's say remove this 10 and as take 1 and 2, 12. Remove this 10 and add 12. Okay. So let's say like D here 1 is present. Yes, 1 is present. So temp will becomes 1 and at the end I will answer maximum of 10 and answer. I will take the maximum. So that is 1. So 12, for the 12 you can see like 1 is present but 2 is present, that no, 2 is not present. So maximum answer is the maximum match bus. What maximum match is this one. So not only 2, let's say 1, 2, 3. Then you will understand what I am saying. 1, 2, 3. Okay, let's do one by one. What I am saying, like I will check what if it is present or not. If present, then I'll do something. If current dot find of my digit, if it is present, I'll do what? I'll simply increase my temp. So temp plus and increase the temp. Another thing, what can I do? My current have to go to the next point. So current equals to current of D. Correct. And if it is not present, then I have to break the loop. So I can otherwise I have to do this thing. So I can check that not present case and break the loop earlier. Otherwise I will do the thing. This is a simple. If it is not present, I'll take this one outside. As I told you, if it is not present, so create extra space here. If it is not present, I will simply break it. No need for doing that. Break. After that, this will end the loop. After the loop ends, I have to update the maximum, right? Like it could be possible by temp is greater than my current answer. It could be possible, correct? So let's take the case. Let's take my maximum assignment. So answer will be answer maximum of answer plus maximum of answer and 10. Okay, this will be my answer. And at the end, this loop will also end, and return what? Return my answer. Return my answer. And here also it ends. So let's write down this code. Okay, this part. So earlier my current was what? Current list. This is my second array. So this is 1. So my 1 is there. Temp is what? Temp is 0. This is temp. So I'll check here. Is temp present here? Yes, temp is present. Right, temp is 0. Temp is present. If it is not present, then I'll break it. If it is present, yes, temp is present. Good thing. So I will link, sorry, the digit is present. So I'll increase the temp. So temp becomes 1. Temp becomes 1, and current becomes this one, current becomes this. But the thing is, this what the digits also ends. So fine. So answer will be answer of max of answer and temp. Max of answer and temp, correct? Maximum of answer of temp. So that could be the case. So my answer will be right now. So answer is earlier 0, it becomes 1. Again my temp is 0 currently. Again I do starting from 1 2 3. So temp is 0. Now I will check 1. 1 is present. Yes, 1 is present. Temp becomes 1. Temp becomes 1. And this current becomes this position. Correct. Then after that what? 2. This 2. So 2 becomes what? So 2, I'll check this 2. 2 is present. 2 is not present inside this one. 2 is not present inside this one. So I simply break. I'll break the list. And answer will be what? Because no point of checking the further things, right? No point of checking further numbers. And my answer will be what? Maximum of answer and temp. Earlier was temp was 1, this was 1. So 1 1 is the case. Okay. So fine. For 100, let's say 100, temp is 0 and number is 100. 1 is present. Yes, 1 is present. Temp becomes 1. 1 becomes my current. 0 is present under 1. Yes, it is present. 0 is present. So temp becomes 2 and current becomes at 0 position. Then what? Again I have to check this 0. It is present or not. Yes, this 0 is also present under this 0. So this is what? Temp becomes 3 and current becomes this 0. Correct. Now what? Now if you notice, my loops like 100 is gone. Now what is my temp? Temp is 3. At the end here I have to check answer equals to maximum of answer and temp. So 3 is the answer. Done. This is done. So last number is 2 3 4 5. So 2 3 4 5 7. Now if you check, like, it is actually 4 5 7. Okay. So first I will check 2 is present or not. 2 is present. Yes. Temp is what? Temp becomes 1. Temp becomes 0. Eligible becomes 1. Now this will point my case. Okay. Now I will check 3. 3 is present. Yes, 3 is present under the 2. 3 is present. So temp becomes 2 and my current becomes the third index. Now I'll check 4. 4 is present under 3. Yes, 4 is also present. So temp becomes my 3 and this pointer will point, like, current will point this 4. Okay, 5. This 5 is present under 7. Yeah, sorry, under 5 is present under 4. Yes, 10 becomes 4 and 5 also present. This pointer is pointing the 5. Now 7, is it present? No, 7 is not present. So I'll break the loop. But answer will becomes at the end 3 becomes 4. Okay. So this is the case. This is the case. Can you optimize this earlier, like we are checking is the case? Like here you can't optimize, like earlier. If you notice, earlier case, we're optimizing while iterating the each number. So I am taking the maximum number, then I am reducing the length of the number. So this is possible. Like this kind of thing is possible. Okay. Here this is not possible. I am iterating from left to right. Left to right. So 1000 and 100 doesn't know like what will come. It becomes like here, like if the number of equal things are same, like all the numbers are same, when we could know, we can check from the back end, like let's say 1 2 3 4 5 and it is 1 2 3 7 6. So i can I can base case all are same. how could I easily find it out? Both our numbers are different. If from traverse from right to left, if anything becomes different, it could be the next number. Okay, so it could be the new number, different number. We can say and break the loop. But here, or anything is matching. If maximum number is matching, like there's 1, 2, 3 is matching. So 1, 2, 3, whenever matching, I can skip like 1, 2, and 1 kind of generating cases. But here it is not possible. Here I have to iterate each and every case, each and every case I have to iterate. Even though like we can see it are the same. Like 100 is containing one, like 1000 is containing 100. Still I have to do this because here 1000 is containing 100, but we don't know it is a 100 or 103. Like here it could be 103. So that's the reason I have to iterate each and every case. So I cannot skip or directly stop like what I did earlier. This kind of thing I can't do it. This kind of thing we can't do it here. So somehow, even though it is a big of in log m, but it is less than big of in log m because average cases, some of the case, like some number is matching. Okay, but here doesn't matter. Here I have to do the same. I'll come the time complexity later. Okay, let's clear these things. So earlier here also, whenever I'm checking, so whenever I'm checking in this position, that time also I'm checking is my length, current length of the number is already greater than my answer. Like it is, if it is less than my current answer, I will not check. Here also we can't check. Here that thing also we can't check because we are checking from left to right. So we are checking for the smallest, then we are finding the largest ladder. So we can't check. One thing we could check, we can check entire digit. If the entire digit is less than my current answer, then only we could skip. Otherwise we couldn't skip. Okay. So for simplicity, like that thing, you can check here this thing, there is one, you can put on check condition here. If you can put one check condition here, if my log of okay, I'm writing the opposite of check function, like log of num plus 1, if it is my less than current answer, less or equals to my answer, that means maximum I can get that many of answer, right? So if it is my maximum of that, log of n plus 1, this is the case, and I simply continue. I will not check, I will continue. Otherwise, I will check. Hope you understand this thing. So let's see what is the time complexity of this problem. So time complexity, nothing but this is also big of n. As you know, n is maximum of n1 and n2. This is also big of n, big of n, big of n. So, and this is also like, this is converting number to string, it will take big of log m, how many digit is present, and you know m is nothing but that. Like I told you, m is, this is the same thing I am following. This is the same notation I want to make. I want to use it. Okay, so this is the same thing I'm using. So this will take also big of n is nothing but the maximum number of this here. And this is also like each, you know what is the length of the string. This is a big of log m only. So this loop also take big of log m, big of log m. Okay, and iterating to the dictionary, it will be everything is a big of one kind of operation. Here also this string thing is also big of log m time, and here also this loop also runs on big of log m. Okay, but this is the same time complexity actually, like log n into log m. Okay, so time complexity, other the space complexity, same thing. Like host case, it will contain dictionary, empty dictionary will contain dictionary or map it will contain. But the thing is, it is much larger than the previous thing. Previous, if you remember, it is a log m. Now maximum case it will everything will be empty dictionary. Okay, everything will be empty dictionary. A dictionary will point to something. Dictionary or map will point something. Let's say one is pointing something, right? It is pointing something. But this pointer, it will have to give you some space, right? If you store the key value and it is pointing to some other space, and this pointer also you have to give some space, right? So even though it is n log m, but it is much higher than that your set, because there is we are considering only key and value, only considering only key and value cases. The thing is, this also considers if the worst case everything is empty. This is empty. This is also empty. This is like worst case. What I'm saying about. Let's say 1 is point to 0 and 0 is empty. 1 is point 1 and that is empty. And 1 is point 2, that is empty. Okay. So in the worst case, everything could be empty, but it is in like every number I have to store something from dictionary. And dictionary, what I am storing, I am storing nothing but log m. Every digit I am storing. So that's what is in log m. So in the dictionary I am storing a digit. See, I am storing a digit. So at the worst case it will be m digit I have to store. Sorry, not m. Log of m digit I have to store. And how many times I have to store this thing? N times. That's why it is. So this one and this one makes you n log m. But what I'm going to explain, like even it's an empty thing, it will point to some dictionary, some space, right? It will point to some null space or none space, right? So this thing. For this, you have to give some extra space. On paper or assembly notation, it will be n log m, but it will be much higher. Like this for dictionary, for mapping in log m is higher than the same space required for the set. Okay. So this is not actually a good solution. Here you can see, here you can skip sometime. You can skip this here, you can skip this here. This kind of time you can skip. Actually, you can bypass your calculation or you can skip the calculation. Here you can't skip. As I told you, here you can't skip. Here overall we can skip, but in the each step you can't skip. So earlier solution, there is a in every step there is a kind of option to skip that step or further calculation. But here only one we can that check this thing, like whether we can skip entire calculation or not saying every step. But that's the thing. So this is actually not, this is the approach one is a better solution. This one is the actually better solution. So why I told you the approach two, because this is another approach and it's a good approach. It's a good problem we will try. So that's why I told you this is another approach. So here approach one is a much better solution compared to the approach two. Okay, I hope you get it. The video is actually gone too longer. Sorry for that. But as always, if you find any mistake in this video, please let me know. And if you find any useful information on this topic, please also let me know so that I can also understand or learn. Okay, bye bye.